Hi, I'm Helen, and I will be explaining the phase changes and how the intermolecular forces of attraction change during phase changes. When substances change from solid to a liquid, the intermolecular forces of attraction decrease in strength, and this process is called melting. Intermolecular forces of attraction also decrease when substances change from liquid to gas. And this process is called vaporization or evaporation. It also decreases when substances change from solid to gas. And this process is called sublimation. When substances change from gas to a liquid, the intermolecular forces of attraction increase in strength, and this process is called condensation. And intermolecular forces of attraction also increase when substances change from a liquid to a solid, and this is called freezing. And when it goes from a gas to a solid, and this is called deposition.
Hi, I'm Emma, and I will be explaining the chart we made on the first page. This chart is split into 3 columns: solid, liquid, and gas. The motion of the particles decreases as you move to the right of the diagram, from solid, liquid, to gas. The shape of the solid is definite because it does not change and it is ordered. The shape of the liquid is indefinite because liquids take the shape of the container that it's in, the same as gases. The volume of solids and liquids is definite because the space it takes up stays the same. In a gas, the volume is indefinite because the gas can take up any space with weak forces. In a solid, particle arrangement is arranged and in neat order. Liquids have similar particle arrangements, but some particles may be displaced or moved. There is no particle arrangement in a gas because everything is freely moving. The particle arrangement explains the entropy of every phase. In the solid, there is no entropy, which means randomness. Liquids have some entropy, and gases have a lot of entropy. The strength of attractive forces gets weaker as you move from solid to liquid to gas because the particles move apart.
Hi, I'm Aileen. So today we're going to be learning about endothermic versus exothermic. Moving on, we have the heat absorbed, which is endothermic, and heat release, which is exothermic. Okay, so let's check the phases of endothermic. So in endothermic, we have solid to liquid to gas, liquid to gas. These are the phases. And exothermic, we have gas to liquid to solid, liquid to solid. And last but not least, we have water to ice, which is a liquid to solid form.
Hi, I'm Steven, and I'll be answering the conclusion questions. When water is freezing, is it releasing heat or taking heat from the environment? It is releasing heat to the environment because the temperature of the water is decreasing. Is this process endothermic or exothermic for the water? It is endothermic because the temperature of the water is decreasing, meaning it is releasing heat to the environment. What are 2 differences between the molecules of liquid water and water vapor? The molecules of water have less entropy, of liquid water have less entropy and motion compared to water vapor. Is this process endothermic or exothermic for water? It is endothermic because the temperature is rising, meaning heat is being drawn from the environment.